We have a saying inside NVIDIA that if you're not at least 10 years before a market or a technology takes shape, we are probably late. So in that spirit, I think it was a perfect timing for us to jump into physical AI, autonomous, robotics type of applications, and we also had the benefit of autonomous vehicles were about to take shape in 2015. So it wasn't like we were completely coming out of left field. So there was early indicators that it's clear that deep learning came about and we should be able to apply this technology. So a lot of our resources went towards autonomous vehicles, and then we were able to leverage that same technology, and along with our complete CUDA stack, if you will, and start building our NVIDIA Jetson computers, which is where we started first in 2014, in fact. And the proof is in the pudding, right? So if you look at it now, our latest generation is Thor, which is now available in August. But the version before that, Orin, which we launched in 2022, has really taken off. We have over 2.2 million developers in robotics that are working on our platform, over 7,000 companies that have either launched some sort of autonomous or semi-autonomous or automation product based on Jetson, or in the process of serious development that is going on. So that's really proof points that even though it feels like we started early, we had to actually start that early in order to bring the market and the technology to a place where it can be broadly adopted.
How difficult of a transition are we talking from this world of LLMs into like actual embodied AI?
Yeah. So I think where the industry mostly is looking at right now is fundamentally using a multimodal reasoning model, right? So this would be, you could say it's LLM, VLM, reasonable size, because you got to run it at the edge inside the robot brain. So today, the best, you mentioned Thor, that's our latest generation, over 2 petaflops of compute that's available in a robot brain. That's amazing. Kind of compared to when we started Jetson 10 years ago, it's 7,000 times more compute that we're providing, in the same form factor. So it's typically, what we're seeing right now is, you end up using several tens of billions of parameter models. That's where the technology is today. You'd use it for reasoning because you need to understand, and you're typically connecting to multiple sensors, right, at the same time. And then once you do the reasoning, you have to do the action after doing the reasoning, and that's where a vision language action model comes in. So what we're seeing most of the research, including our project Groot, typically what we do is we have we use a reasoning model as the front end, and then we have a vision language action model, and that's kind of where most of the industry is currently exploring. And vision language or action models, VLAs as they're called, typically in the 2 to 5 billion parameter model. So that's kind of where the state of the art today is. But as we and the job number one right now is accuracy, right? If you don't get it fairly accurate to where you want to get to, if you just run it super fast, it might not be that useful. So what we are working on is on both the fronts, which is the accuracy needs to be sufficiently good for whatever task you're trying to do, and then optimize it to get reasonable performance. And then we know that based on all the work that we're doing in terms of performance and perf per watt and perf per watt per dollar, that trend, NVIDIA with accelerated computing, we are aggressively on a roadmap to, whether it's data center or whether it's in a workstation or in a Jetson, we are aggressively on that path to keep improving generation over generation. So that's kind of where we are today. So leveraging multimodal models for reasoning, and then creating a action model for doing the physical actuation, and that loop, of course, continuously goes on.
I feel like it's interesting to watch this kind of evolution in how people are thinking about these robots that even like what we consider humanoids are going to come in all sorts of shapes and sizes and form factors.
Yeah, I mean, it's pretty logical to expect that there will be multiple embodiments. And in fact, many people ask me and NVIDIA, and for that matter, other experts, is humanoid the right form factor exactly to look like a human? And the answer is yes and no. There are certain jobs that it makes sense, and there are certain other spaces where mobile manipulators make sense for cost reasons or, for other reasons, right? Ability. But the beautiful thing about what's happening in the industry, irrespective of the embodiment, we think it's going to be many, many different embodiments. But the beautiful thing about what's happening with humanoid, even though some might feel like we are pushing it way too much and it's hype, because of the opportunity, the best in the world are gravitating towards it to solve the number one problem that we need to solve, which is to create a general purpose brain. And testing that general purpose brain in a humanoid form factor makes logical sense, because in the last 200 years we built the whole world around to be around human form factors. It's brownfield, so it's logical that we can do a lot of testing in that form factor. It doesn't mean that our deployments, final embodiments, 100% need to be that. There can be many different embodiments. But the beautiful thing is, if you're able to create the general purpose brain, then we can adapt the general purpose brain to different form factors and different use cases along the way. But job number one right now is we need to create a chat GPT equivalent for a physical robot today. And that does not exist. And that's where the whole world is at the problem right now to create it.